Hello everyone, welcome to Indomitable Tech. This is Shaunak Deshpande, and in this particular notebook we will be taking a look at how to do anomaly detection using statistical methods. This notebook will be kept on GitHub. Make sure to check the link in the description, and if you want to see the dataset, which dataset we are using, I have mentioned the link in the first code block of the notebook itself on Kaggle. It is Twitter mention volumes. So this dataset consists of a column which is a timestamp where you have date and time of the when the count of tweets is recorded, and you have different companies: Apple, Amazon, Salesforce, Facebook, etc., for whom the number of tweets which were tweeted at this particular time is mentioned. So for univariate analysis we will be taking a look at Apple. So let's begin. So first we'll be importing libraries. We'll be making use of pandas for data wrangling, SciPy for ZScore, and Plotly for graphical representation. We are going to look at three methods: standard deviation, ZScore, and interquartile range. So let us quickly, I'll just increase the visibility so it will be easier for you to look at the code. So caps lock was on. Import pandas as pd, then from scipy dot stats import ZScore, and then Plotly express. We are going to make use of Plotly express. So import Plotly dot express as px. This import warnings and this particular two lines of code, this is, you can ignore that because I have mentioned that just so we can ignore the warnings which Jupyter throws up. Okay, so it is executed. Let's move on. So we'll be pre-processing the data. So let us first read this particular data set. It is kept on my local machine at this particular path. So RawDF, that will be the name of our raw data frame which we are going to read. pd dot read csv, and then I'll pass this path. And from this path we do not want all these columns. We are going to analyze only for Apple. For practice purpose you can analyze for other companies. For demonstration purpose in this video I am going to focus only on Apple. So we are going to make use of these two columns, timestamp and Apple. So here in use calls I am going to use timestamp. I am going to pass in the list. So use call will only read the number of the columns which we are mentioning over here. So the first column is timestamp, and the second column I am not going to hard code it. I am going to pass this company as the variable. So in case if you want to reuse this particular notebook, you just have to change the name of the company to a different name of the company like Amazon or Salesforce. So that is done. Now if you want to take a look at this data frame, how it is appearing, let's take a look at the first rows. This is how it is appearing: timestamp and the number of tweet mentions. So for 26th of February 2015 at 21 hours 42 minutes 53 seconds, Apple was mentioned 104 times on Twitter. Now moving ahead, if you want to take a look at data type of columns, so ideally this is date time timestamp, so it should appear as date time, but sometimes it may be the case that it is not appearing as date time. So just to make sure it is in the right data format, let's take a look. Also this Apple, it should be in terms of the counts, should always be in terms of integer. Sometimes it can be in string format as well. So we just need to check and make sure the data types are in the required format. If not, we have to convert those data types. So RawDF.info, this will give you the information about the columns. So timestamp, there are in total 15,902 observations, and data type is object. So we do not want data type as object, we want it as date type. And apple is int64, so which is integer, so that is okay, because while making use of, when we are going to analyze the number of tweets to detect anomalies, we want it in terms of number, so it is already in integer, so that is good. So what we will first do is we will aggregate all the tweets on hourly basis. So if you see, for 21 hours there are 4 observations. So what we will do is we will ignore minutes and seconds and we will only keep it as hours. So we are able to group based upon the hours. So we will be analyzing the tweets on hourly basis, and we will aggregate the number of tweets on hourly basis. So we will take addition, we'll add all these 4, so we will get the number of tweets which are mentioned at 21 hours. For that purpose, let us write a function. So RawDF, and name of this particular column timestamp. And map lambda. So map method allows you to apply a function to this particular column timestamp. Lambda value, instead of value I will mention date because it is a date. So date, and what we will do is we will first break down this date. It is already in string format, this date. So date dot split, and we are going to split here on the first column. So we will consider only this particular part, and this part we will convert it to 0 0. So we will split, take the first part, and we will take the first part, and then the remaining part will be 0 0. So I am going to make use of f string, and the first part, which is the variable part, I am going to put it in curly brackets. So it is able to take the date, split it based upon the first column, and then take only the first part. So we are going to take only the first part, which is the date and hour, and replace the remaining with 0 0. Now let us execute. Upon execution, if you see RawDF, it is appearing 0 0. So we will be able to group this data frame based upon date and hour. Moving ahead, convert data type to timestamp, of timestamp to date time. So if we checked using the info method that the data type for timestamp is currently object, so we will convert the data type for timestamp to date time. So RawDF timestamp, copy this. So how to convert to date time? It is pd dot to date time, and here we pass the column, and upon execution it is converted to date time, because if you see raw underscore df dot info, if I now execute, you see timestamp converted to date time. Now that is done. Let us check for missing values. Are there any missing values? So for missing values, you say is NA, are there any missing value? This returns a boolean whether it is true or false, but we don't want that, we want the sum of it. So for both the columns there aren't any missing values, so which is good. So drop or impute the missing values, we can ignore this. So I'll just remove this and then recheck missing values. I'll remove this code block because there aren't any missing values. Now let us group the tweet mentions by hour. So what we will do, we are going to group these tweets based upon the date and hour, and we are going to add the number of tweets for that particular hour. So we get total number of tweet mentions for that particular hour. So RawDF equal to RawDF dot group by and we are going to group by timestamp. Here it is by and timestamp, and as index equal to false. The reason why I am mentioning as index equal to false is because this timestamp, we want this timestamp as a different column. If I do not mention it, timestamp will be converted to index. So instead of 0, 1, 2, 3, 4, it will be replaced by this timestamp, which is this date and hour. So I do not want that, so I am mentioning as index as false, and then we will sum it. So if you see RawDF dot head, so instead of earlier we were getting 21 hours, we were getting 4 observations. Now we are getting only 1 observation, 457. So now our pre-processing is done. I am just going to write 2 functions. One is make graph and another one is check. Make graph will take input of data frame x axis, y axis, and name of the anomaly column, and then it will plot a graph. We are going to make use of plotly to plot the graphs. So I have mentioned the details over here in this docstring, what this particular function does and what are the input parameters we are taking. Output parameters, there aren't any output parameters, it will just plot a graph. So let us quickly do that. So fig equal to px dot scatter. We are using plotly over here, plotly express px scatter, and data frame equal to the data frame that we will be passing. X will be x underscore call for column x column, name of the x column. Y equal to y underscore call, and then color will be based upon this anomaly color. So if it is anomaly, it will be displayed in one color. If it is normal, it will be displayed in another color. So this is done. Then fig dot update layout, that is, if you in update layout we will be passing the title of the plot and then x axis label and y axis label. So title will be, let's put it in f string. So let's mention it as anomaly detection for company. This company which we have selected here for Apple, it will show Apple for company using the method. So this method is going to be one of 3: standard deviation, ZScore, or interquartile range. And then finally fig.show, this will display the graph. So this is done. Moving on, check. So what this check function will do, it will take the value and it will compare it against upper limit and lower limit. So in statistical method that we are going to see, if the value is lying between upper and lower limit, then it is a normal value. If it is beyond the upper limit or less than lower limit, then it will be classified as anomaly. So let us do that. If value, so I will write it over here, if value is greater than lower limit and less than upper limit, then it will return as normal, else it will return as anomaly. So if you want to see a demonstration for check, so value equal to, let's say, 5, and then upper limit is 9 and lower limit is 3. If I execute it, it will show as normal. But if I reduce the value from 5 to 2, it will show as anomaly. Now comes the actual part of this particular video. So we are going to see standard deviation first. So the usual formula for upper limit and lower limit for standard deviation is mean plus or minus 2 times standard deviation. So this 2 factor that might get converted to 3 depending upon the use case that you are looking at. So for this particular use case is nothing but example. So for this particular example, we are going to keep the factor as 2. So upper limit will be mean plus 2 times standard deviation and lower limit will be mean minus 2 times standard deviation. So let us calculate mean. So RawDF dot mean, this will give us the mean, and RawDF dot std will give us the standard deviation. And if I execute it, mean is appearing like this for apple, and standard deviation, this is the standard deviation, and this was the mean. Now upper limit and lower limit, let us calculate that. So upper limit is mean, since we only are interested in taking the company value, mean plus minus 2 times standard deviation. Let me just quickly fix this indentation. Here it is minus because it is lower limit, 2 times standard deviation, and here I will mention as company, so it takes only for the apple column. So upper limit, lower limit standard deviation. So this is how it is appearing. 6987 is the upper limit and lower limit is 4935. It is negative 4935, so obviously the number of tweet mentions cannot be less than 0, so we can ignore the lower limit in this particular case. Now let us plot the graph and first calculate the anomalies. So form a data frame. So let us quickly do that with timestamp and tweet mention count. So we already have that. So RawDF, that is our data frame. Create a column which tells us the values are normal or anomaly. So RawDF, for this particular case, let me quickly create a data frame. Sorry, my bad. So here I should have created a data frame because we are going to add a column by the name of anomaly to this particular data frame based upon standard deviation. So std dev data frame, standard deviation data frame equal to RawDF dot copy. We are making copy of RawDF, and here we are going to make use of anomaly. This will be the name of the column which will store the information whether the given observation is anomaly or not. So we are going to make use of std dev df and company, because company column has the number of tweet mentions. This column, apple column, we are going to apply the logic over here. So if 457 lies between upper and lower limit, then it is normal. If not, it is an anomaly. So the same logic we are going to apply over here. Dot map, and here we are going to make use of lambda expression value if. So we are going to pass this value in this check function that we wrote. So it will nothing but check whether it lies between lower limit and upper limit. If not, it is an anomaly. If it lies in this limit, then in this range, then it is a normal value. So in check value equal to value, then upper limit is this upper limit standard deviation, and this lower limit is this lower limit standard deviation. Now just reformat this code block so it is visible. Standard deviation. Okay, it is lambda. I forgot to mention d over here. And lastly, let us represent it graphically. So let's make use of the make graph custom function that we wrote. So method is this method name standard deviation, then data frame is this std_dev, then x column is timestamp because we'll be having time on x axis, and y column is company, that is this column, this Apple. So timestamp is on x axis and number of tweet mentions will be on y axis, and name of anomaly column is anomaly, which we created using this lambda expression. So let us plot it. Make graph. Okay, method method. So upon execution, this is how it is appearing. Anomaly detection for Apple using standard deviation. Blue dots are normal and the red one are anomaly. So if you see for this particular red dot, so anomaly timestamp, it was on 16th of March 2015 at 2 o'clock, and the number of tweets mentioned was 28.14 thousand. So this is how we are doing the anomaly detection using standard deviation. Now moving on, after seeing this particular case, the remaining two will be easier to understand. So similar to upper and lower values for standard deviation, for Z-score we are going to first set up a Z-score threshold. So this Z-score threshold usually lies between 2 and 3. So for upper cutoff score it lies between 2 and 3, and lower cutoff score usually lies between -2 and -3. So Z-score threshold for this particular example, I am going to keep it at 2.5. So let us quickly form a data frame. We are going to do the exact same thing which we did over here. So let me name it as ZScore df and make a copy of RawDF, and I'll calculate ZScore df, and I'm going to apply this Z-score on this company, and I am going to save this in a column called as Z-score, and this Z-score is the method which we have imported from SciPy. From scipy.stats import Z-score. The same thing we are going to apply over here, Z-score, and then once we get the Z-score, we are going to create an anomaly column. This should be Z-score df. Okay, Z-score df anomaly. So the values in Z-score, if that value lies between plus 22.5 and minus 2.5, then it will be normal. If it is greater than 2.5 or less than minus 2.5, then it will be classified as anomaly. So let us do that. Z-score df Z-score dot map lambda value. So normal if this value lies between, if this value is greater than minus Z-score threshold and it is less than plus Z-score threshold. Normal if this, else anomaly. So I have just applied this if else statement. So if this value lies between negative Z-score threshold and positive Z-score threshold, then it will be classified as normal, otherwise and it will be classified as anomaly. Now let's do the same thing, graphical representation. Make graph, method is Z-score, data frame is this Z-score df, X column will be timestamp, Y column will be company, that is Apple, and then anomaly column is this anomaly. Now on executing this code block, we have got this graph: anomaly detection for Apple using ZScore. Blue dots are anomaly and red dots are blue dots are normal and red dots are anomaly. So again, for this particular example, let us check this dot. On April 14, 2015 at 22 hours, it has detected this dot as anomaly because Apple was mentioned in tweets 16,628,000 times. Now moving on to the last part of this video, interquartile range. So if you have ever plotted box plot, so box plot is interquartile range. It is easier to understand interquartile range using box plot. So usually if you see an outlier and if you make use of interquartile range, you will be able to understand the outliers and deal with them. So what it does, interquartile range, it counts the first and third quartile, and interquartile range is the difference between the third quartile and first quartile, and upper and lower limit set are based upon this formula. Upper limit equal to third quartile plus 1.5 times interquartile range, and lower limit is first quartile minus 1.5 times interquartile range. So let us quickly do that, calculate it. So Q1 equal to RawDF company, and we are going to calculate the first quartile for this value for Apple, numeric column. So while calculating, you have to write it as quantile instead of quartile, and 0.25 at 25% you will get the first quartile. Similarly for third quartile, it is RawDF company. So we get the series for Apple, the numeric column, and then quantile. Third quartile will be for 0.75, that is at 75%, and difference between Q3 and Q1 will be our interquartile range, IQR. Now upper limit, it is Q3 plus 1.5 times IQR, and lower limit Q1 minus 1.5 times IQR. Now if I show the values, upper limit IQR, lower limit IQR, so these are the values. 1776.875 is the upper value, lower limit is minus 450.125. so we can disregard this, we can ignore this lower limit because tweets can never be negative. So let us quickly do the same thing which we did earlier. Make a data frame, check whether the values are anomaly or not by checking whether they are lying in this upper or lower limit range, and then plotting the graph if it is anomaly or not. So IQR DF equal to RawDF dot copy. We are making copy of this RawDF, and then we are going to create a column called as anomaly. IQR DF anomaly equal to IQR company. We are going to apply the same lambda expression dot map lambda value, and we are going to check whether value lies in lower limit and upper limit. So we are going to make use of this check method, check function, which we already defined here, this particular function check. So value equal to value, upper limit is this upper limit interquartile range, and lower limit equal to lower limit interquartile range. For I am just going to reformat this code block so it is easier to read. Now this is done. Make graph method equal to method name. Here method name is interquartile range. We are just going to make use of this string while giving the title of the graph. That's where this method is getting used. Then data frame is IQRDF. X column is timestamp. Y column is name of the company, and then anomaly column is anomaly. And on execution we are getting this graph. Anomaly detection for Apple using interquartile range. Blue dots are the normal ones and red dots are the anomaly ones. So for example, for this particular case, on 21st of April 2015 at 8 o'clock, there were 16,534 mention of Apple in tweets. So we discussed three methods in this particular video: standard deviation method, ZScore, and interquartile range. So there are other notebooks as well for machine learning and anomaly detection. This was statistics based. There is also a notebook which is machine learning based, where I have made use of one class SVM, then isolation forest, etc. So if you are interested, you can take a look at that notebook as well, and I also created a video for that. It is in the playlist. And that's all for this particular video. This was Shaunak helping you out with statistics based anomaly detection. If you have any queries, you can mention it in the comments. If you want to get back to me, or if you want to do a project, collaborate with me, I'll be mentioning my email at the bottom of this notebook. So take care and thanks for being here. Thanks. Bye.